Mindsetters, welcome to Learn Extra Live Grade 11 Mathematics. Hello Natasha, how are you?
Hi Katlego, nice to see you.
Nice to see you too on this awesomely warm Monday. It's also warm in the studio, although we can't see the sun, we know that it's warm. Thank you guys so much for joining us. As you know, or may not know, we are doing 2D trigonometry. Please tell us more.
Well, grade 11s, you know that we started with 2D trig last week, so we're going to continue on that. Just do a little recap and then some slightly harder examples, not very hard.
Okay, well, we like a great challenge, so that should be exciting. You can go over to your board.
Thank you.
So guys, since it is Monday, we have some awesome prizes to give away. We have the Casio calculator, as well as the labeler. So make sure today you are the most awesome mindsetter so that you can win these prizes. And thank you to Liberty as well for bringing us this show. If you do want to win or ask us questions or just to be involved in our show, make sure that you are on Facebook right now, www.facebook.com/LearnExtra, and our Twitter handle is @LearnExtra. Make sure that today, guys, I know that you like trig already, so just make sure that you're even more involved than any other show that you've ever been on, and I will notice that. Trust me, I am here just waiting and dying to hear from you guys. So make sure that you are the shining star today. Over to you, Natasha.
Thanks so much, Katlego. So guys, we are carrying on with 2D trigonometry. Remember, we started it last week. Last week, I went very, very slowly, showed you so much of detail, and helped you to understand where to use what ratios. So to start off, we're going to do a quick recap of all the different formulae you can use. Remember, we first look at formulae in grade 11 where you do not have a 90-degree triangle. So the first few formulae we look at, you don't have a 90-degree triangle, and then we'll just remind you at the end a little bit about what Dina was doing with the grade 10s in the right angle triangles. Okay, so let's have a look. So as I said, it's just a recap from last week. Some of the formulae. We've said that the sine rule can be used when we know more than one angle and a side, or if we know two sides and an angle. So if I have some triangle, and I'm just going to draw this in here, and we call this triangle A, B, C. Remember, when we label our sides with the little a's and the little b's, the side opposite angle B is called little b, the side opposite angle C is called little c, and the side opposite angle A is little a. So the sine rule, it says if we have more than one angled and a side, or two sides and an angle, we can use the sine rule. The formula for the sine rule is A over sine A is equal to B over sine B is equal to C over sine C. Now, it's just a force of habit that I always start with the sides on the top, but you can swap this formula around and say sine A over A is equal to sine B over B is equal to sine C over C. It's perfectly acceptable, okay? But obviously don't do some combination of this one and the other one. Okay, make sure that if you're starting with the side on top, then your next equal to needs to also start with the side. All right, then let's move on to the cos rule. Remember, your cosine rule can be used when you have three sides. Obviously, if you have three sides, it means you'll be looking for an angle, or if you have two sides and an included angle. So if I take any side in this triangle, say we're looking for side A, all right, then the formula will be A squared, and you guys should know this so well by now because we have been doing it for quite some time. A squared is equal to B squared plus C squared, so it's the sum of the square of the other two sides minus 2BC cos of the included angle, so it would be cos of angle A. All right? And then remember that you can manipulate this formula, so you can turn it around and you can take all your letters to the other side, divide by your 2BC, and then you'll be looking for your angle A. All right, and then without a 90-degree triangle. Remember, in a 90-degree triangle, if you are given the base and the height, to find the area of the triangle, very easy. It's a half base times height. If we have a triangle where we don't have the base and we don't have the height, then we can use the area rule. And all you need to know here is 2 sides and the included angle. And the formula for the area of the triangle, ABC, is going to be a half AB sine C. So again, if we go and look at our diagram, if I'm using a half A times B sine of C, I obviously will need to know what that angle is, and I would need to know what the length of this AC is and what the length of side BC is in order to use the area rule. And we can swap it around depending on which sides you've got and which angles you've got. You can swap that formula around. All right, then just a reminder, and if you were listening to the grade 10 lesson, you would have picked this up with Dina, but in a right angle triangle, if you want to solve the triangle, you can use your SOHCAHTOA definitions. Remember, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. All right, so that works in a 90-degree triangle. If you have at least two of the sides, you can also use Pythagoras' theorem. Remember that one, where x squared plus y squared is equal to r squared. So if you've got any of the 2 lengths in a right angle triangle, then you can find the other one using Pythagoras. All right, so that's just a brief recap of what we did last week. And just remember that these formulae will be given to you, except for the ones at the bottom with the SOHCAHTOA and Pythagoras, the sine, cos, area rules. They will be given to you, but you need to know how to apply it and when to apply it. And last week we looked at a diagram that I gave you and showed you how to start a 2D trig problem. Remember, you've got to identify your triangles, identify the triangles with the most information, and that's where you start working. And then you always look for a joining side, so a side that joins 2 triangles together, and that will take you from the one with the most information to the one where you need to be. All right, so what we're going to do is, I think after this recap, maybe take a quick break and then come back with our first question.
Okay, that's awesome. Let's take a break just so that you guys can also just get your minds straight about what we're doing today and anything that you'd like to ask based on what we're doing. And when we come back, we will dig right into the awesome stuff. See you after the break.